I have no doubt in my mind that there's only one country that can really challenge China in this segment, and that is India. So I don't see how we cannot become an EV hub for the world.
What is battery recycling?
India as a country does not have any of these minerals that go into a battery. And I realized that these are being mined in only certain specific parts of the world, which are completely dominated by China.
I think within this India EV show, right, this is a second big revelation on regulation is that there is no regulation on second life. Actually, this has to be because this is an asset which is going inside someone's house, which can power the batteries, but at the same time, it can take lives. If someone wants to create a business in the EV space, which are the couple of opportunities that you would want to recommend people?
I see a lot of recyclers, a lot, but it's a tough business. Find your raw material, otherwise don't build a plant.
What are the common mistakes that you see entrepreneurs doing?
Be agile, be flexible. Our industry moves at a furious pace, quicker than you and me can think. There are many factors, right? It's not only what we're doing in India, but we're influenced by what's happening in the rest of the world too.
How big is this industry going to become?
The second life business, I believe,
Great, welcome guys. This is again the same India EV show. We are powering India's green revolution, EV revolution. This podcast, KaashSeAkash podcast, India EV show leg is only to learn where we are. हम भारत देश में EV को लेके आज कहाँ पे हैं, 2030 तक कहाँ पहुँचेंगे, राइट? प्लान ये है कि हमें 100% इलेक्ट्रिफिकेशन बहुत जल्दी करना है और उसके लिए इस पॉडकास्ट में वी लर्न अ लॉट. टुडे वी हैव अ वेरी स्पेशल गेस्ट जो कि आ रहे हैं रिसाइकलिंग इंडस्ट्री से, गौरव. सो वील डिग डाइव डीपर. दिस पॉडकास्ट इज प्रेजेंटेड बाय मोटोवोल्ट, who is a great two-wheeler maker, and also sponsored by Redon, which is a battery maker. So guys, welcome. And yes, it is presented in the Zip Electric office by me, Zip Electric founder, right, Akash. And welcome, Gaurav.
Thank you. Thank you very much.
Thank you so much for coming all the way from Mumbai, right? And it's a pleasure to have you. Let's get into the podcast. सबसे पहले मैं पूछना चाहूँगा कि LicoMat, LiCo Materials बनने से पहले where was Gaurav? What is Gaurav's journey? कहाँ से आते हो? क्या किया है? Let's talk about that.
So my background is I'm a commodity trader. Worked in minerals outside India, basically focused on the Indian market for steel and cement, but based out of Singapore. So the thought process for me is looking at what is happening in the electric vehicle segment across the world in 2021, following the mineral trail, realizing lithium, cobalt, nickel are very essential for this. And then figuring out, honestly, like a trader, where can I sell these minerals? Very quickly realizing India does not have any cell manufacturing. So where am I going to sell them? Then I thought about, okay, what is my other avenue of finding these minerals? And that led me to end-of-life batteries. We realized that lead-acid battery recycling is, very mature, very steady kind of business. Lithium-ion battery recycling in 2021, when we founded LICO, we did not see much online or at least on the ground on what was going on, except for China. Because just like everything else in this space, they've been doing this for a long time. So that's where we started, and here we are today.
Awesome. No, so you are into mineral space. You are into battery recycling space. LicoMat is the name of the company. It started in 2021, right? 4 things are very clear, but I want to still understand कि गौरव ने उससे पहले क्या किया? आप commodity trader थे, right? बचपन कैसा था? क्या prompt किया कि आपको ये business खुद बनाना चाहिए, right? मतलब उससे पहले भी क्या business ही कर रहे थे, नौकरी कर रहे थे, वो सब बताओ पहले.
I'm born and raised in the UAE. My father had his own business. So I was educated there, and I went away to university in the US. I wanted to do chemical engineering, ended up doing industrial. And then I came back to the UAE, and I was in business with my father. I didn't quite enjoy what he was doing.
You didn't?
I didn't.
Why?
It was a very traditional business, oil and gas, which was a bit boring for me. So that's when I started my own commodity trading firm in Singapore and trading in minerals.
Own firm.
Yeah, that was my own firm that we were trading in minerals.
So your dad's business.
Yeah, once I told him that
How long did you work with him?
7, 8 years.
7, 8 years in the family. Dad's business.
Yeah, correct. And then I told him that I would like to do something different. And of course, for him, I don't think it was an easy decision because at the end of the day, I don't have another brother to take over the business. But I felt that that business had run its course. Times are changing, evolving, and it wasn't interesting for me. So trading in minerals, commodities, bringing them into India for the cement and steel industry mainly. And so it gives me a fairly good understanding of what minerals are available in India and what we can source from outside. Then that led us to EV batteries and ultimately recycling. And then, of course, from 2021, it's been my full-time job, you can say, for just recycling lithium-ion batteries and focus on that.
So 2021 was when LiCo was formed as a company. Usse pehle you were still trying some of the minerals in EV space?
In other minerals
Which is clear.
for the steel and cement industry. If I'm 21, I started LiCo, and then I slowly stopped that business of the mineral trading commodity because I needed my entire focus to be on this.
Wow. So this is a private limited? Yes. Okay. And you are the sole owner, or is it like a funded company or bootstrapped?
Bootstrapped, only two shareholders in this company.
It's all bootstrapped. Yeah?
Yeah, currently we are completely privately held, no external money.
Okay. And again, how do you decide? I mean, did you have enough capital to invest, or you said that I want to keep the control to myself, I would not want to raise any capital, or it was okay to in this industry? Because this is also capital intensive industry, I understand.
Yeah, and also extremely working capital intensive. So I think the one big difference that I see a lot of young guys who say that they want to get into battery recycling, and they write to me several times that, can you guide us, can you teach us? The one big clarification I would always like to say, is CapEx is only one part of it. This is actually a working capital intensive business because you need to buy raw material to feed your plant, and raw material is expensive, and you need a lot of it because, I mean, today we're saying we have a capacity of over 15,000 tons per year. That's a large capacity. So if we have to, we need working capital of 20, 30, 40 crores per month. So if you're going to build a plant at 10, 15 crores, then you still need to have the rest. Otherwise, there's no point. So I think people kind of missed that boat. But so we said, yeah, we had the capital to do it ourselves. And so far, we've done it ourselves. As we expand and go downstream and look to set up a chemical plant to process what we're doing, a mechanical separation, and then process the next, of course, the investment sizes get larger and larger. So at some point, we would look to raise money as well.
Understood. So now I'm getting to the point that yes, Gaurav had capital to start the business. Gaurav got into battery recycling as an opportunity, right? But why battery recycling? Because you had a background in minerals, and that was closer to something that you understand. Right. Yeah. You bootstrapped it, you put in your own capital. Now, please explain what is battery recycling.
In 2021, when I first maybe started making my project report on this business to understand, is there a business case? The first thing I noticed is that India as a country does not have any of these minerals that go into a battery, whether it's lithium, nickel, cobalt. And I realized that these are being mined in only certain specific parts of the world, which are completely dominated by China. Electrification for us is inevitable. I don't think I think we've reached that point where we can all agree that electrification will happen. It could be a matter of time. Some countries sooner, some countries later. But there's no doubt in our minds, right, that this is going to happen. It's inevitable. The best part that I feel in India is that the government is pushing for it. So when you have the government pushing for the same things you want, I think the likelihood of it succeeding is much higher. So the point was, okay, if we don't have these minerals, what happens to these batteries when they reach end of life? Because those minerals don't go anywhere. They're still there. How can we recover them and put them back into the supply chain? So the answer was, look, at this point, nobody does battery recycling. These probably end up going in a landfill. Now, when Plastic going in a landfill is a different question, and critical minerals like these, which are not even found in our country, going into a landfill would be, I thought, a shame. So how can we recycle these? No technology available, no information available. Hardly a few companies outside of China who had just begun operations. We could not go there. They could not come here. So I think, we decided to take an educated guess and say that, let's listen, we live in Mumbai, let's set up a plant. Not a big plant, but at least let's learn the business. We did not know where we're going to get material from. We did not know who's going to buy our finished goods. There was no regulation in our country, no battery waste management rules, absolutely no idea. But I think I look back at those times and I feel that, it could have gone south very badly, very quickly.
Really? But I mean, you just jumped into it.
Yeah, I think we were convinced that where are these batteries going to go? There has to be a solution, right? Somebody has to provide it.
Wow. You're very clear that this problem exists. Correct. I do not know anything. Let me jump into it. But you didn't think of making batteries at that point in time?
I think there were some people doing it, enough people, and I don't know how I would add any value or be any different. I don't know how, what differentiation we would bring. Mm-hmm. Most importantly, I don't think I'm an electronic guy. I'm a chemical background, so I understand that. I think even today we are in the second life business, but I have to rely on my team a lot to understand how to build a pack, because personally, it's still, electronics is not my forte, probably more chemical.
Got it. So chemical, and now, see, you talked about chemical separation, right? So just to make it very easy for the audience to understand, there's a battery which an electric vehicle needs. We are talking about that, which goes into a car or a scooter or a three-wheeler, right, to power them, and possibly drones also, right? We'll talk about that. Now, these batteries go through various forms of life. First life is to use in an active usage. The second life is to use it in a slow energy usage kind of a thing, energy density. And then when that is also done after a few years, which maybe you will explain better, you separate those chemicals of the cell and sell those chemicals again so that they can be formed in another cell again?
Yeah.
Or what?
Correct. So that's the gist. You're right. Yeah. So we at LICO do a mechanical separation process. This means we get batteries from two-wheeler, three-wheeler, four-wheeler, even bus. What we do is we have about 200 people who work there who just disassemble these batteries, because we don't get one kind of battery.
It's a battery box.
Correct. We get battery packs. We get so many different models, so many different manufacturers in India, so many different OEMs, vehicle OEMs, battery OEMs. So first of all, these packs need to be physically dismantled. Right? Today, there's no way of automating because we don't have those volumes of one particular type. So we still have to have a a physical dismantling first, discharge, manual process. So dismantling it, going down, pack to module, module to cell.
A line of cells and then a cell.
Right. Going to cell. We then test each cell to see whether it has any residual life, so that it can use for second life. That second life use case for us is energy storage. Okay. Because in India, the moment from taking batteries out of mobility, we cannot put them back into mobility.
Right. Why? Because of?
There are guidelines that are being built for refurbishers. Today, they don't exist. It's something the government, CPCB, and all of us are still working on them together. But I think that if we go back into mobility, I don't think many companies will still follow a safe protocol, because we are still looking at NMC.
Correct.
Right? So if the NMC packs are not put back with the actual active cooling and good BMS and stuff, we will have chances of fire. And what will happen in a second life scenario where people want to cut corners, they will cut on safety. So anyway, my point is that we should be looking at energy storage. We are an energy deficit country. There are a good cases for energy storage.
Energy storage. Yeah. 1 second. So I understand that first you said that if a battery pack, we are taking an example, was used in a scooter, that's the first life. Yeah. Now you're saying that there's another thing called energy storage, right? Where it is the second life. Right. Now, energy storage, can you just make it easier for the audience to understand?
Like an alternate to a UPS inverter, alternate to a DG set, any kind of application where we can store energy in this battery and give it to you when you don't have reliability on the grid or fluctuation or.
So this stored energy, typically the purpose is a UPS in most of the
Yeah,
cases?
could be a backup,
Okay, or a backup, UPS or a backup.
like a UPS backup application. It could be a DG, replacing a DG application.
बट डीजी में ये बैटरी इंजन नहीं होती. डीजी रन्स विद ऑयल, यू आर सेइंग. तो अब वो फ्यूल यूज करने की जगह डीजी सेट में बैटरी लगा दी है, वेयर द एनर्जी स्टोर्ड. द मोमेंट इट नीड्स इट, वो जो स्कूटर में चली हुई बैटरी थी, द सेम स्कूटर बैटरी इज नाउ गोइंग इनटू अनदर पैक, बट इट्स फॉर whenever you need it. It's not high energy usage. Correct?
For that, we use more packs coming out of cars.
Okay.
The smaller packs, like basically 20 kilowatt and below, we are using with cells, cylindrical cells that are coming out of scooters, two-wheelers, three-wheelers. But for the larger packs, the 100 kilowatt, 80 kilowatt, 120 kilowatt that we're building, that is coming out of from
Car batteries. So car batteries are the ones that you use first to get into energy storage?
Depending on what we get, either or. We use both.
Okay. So this is second life, energy storage mainly, right? You do this also
Yes.
in LiCo.
Yes.
Okay. So you pick the first-hand used batteries after a certain life, and this is the first task that LiCo does, which is energy storage. So you recreate an energy storage,
Our own pack.
your own pack. Who would be your customers in this case?
Currently, we've deployed them at use cases like schools, clinics, industrial backup, residential backup. You can imagine power backups for so many different applications across our country. So if we believe that it's with Second Life we can compete with lead acid batteries, which are currently used along with inverters. So if you want to power your home for 2 hours a day as a backup, yes, there's a solution we have. And of course, if there are certain parts of India where there are schools for children or clinics or hostels or universities, or small hospitals, clinics where people are not getting electricity 24 hours, and that obviously affects how long children can be in school and how medically assisted they can be. So I think that's a good solution that we are providing. Where power cuts are frequent, but not like the entire day, maybe 2 hours, 3 hours.
So typically it's like a inverter solution for large use case like a school. And what you're replacing here is a lead acid battery
With a lithium-ion battery.
That's the big change that you're doing. Why is this change required? Anything that you want to talk about? Why lead acid was not good or not efficient? Why we are moving to lithium?
Lead acid batteries typically die in about a year and a half. If you have an inverter at home, you would see that their life is 1.5 odd year. I think lithium-ion batteries, we are able to give somewhere between 3 to 5 years. So obviously your ROI is there on that. But apart from that, of course, if you look at the replacement of a DG, clearly it's an environmentally sustainable solution, and at 1/3 the operating costs of fuel.
The second point that you talked about, one movement is lead acid to lithium. The second movement is oil to lithium also, because now you're replacing a very pollution creating and costlier.
Correct. With a battery energy storage.
And that to a second life, which is already used as first life.
The only thing, of course, is still we are trying to draw up regulation around Second Life, because that is still something that we're working with government bodies to make an outline on, because that is still not clearly defined. Not yet.
So Second Life, typically there's no certification?
Not yet. There's some regulation that, it's in the battery waste management rules, but there is no standard operating procedure on how to make a Second Life battery. It's important because what will happen, I'm sure it's already happening in the informal sector, right? It already happens in that, but it doesn't happen in a safe way. And that's the worry with NMC, if not handled properly.
Oh, yeah. So what you're saying is like there's an AIS certification when you make the battery for the first life. There's certification for vehicles and everything. You're saying in the second life, if I use packs of 3 vehicles and create one energy storage system, there's no regulation around it.
Not yet.
So safety has to be done by you as a company.
Correct. We could do that, but not everybody will.
No, there must be a regulation then. I think we should talk about it.
Definitely. I think it's really required. It's extremely important. But sometimes we are more reactive. So we don't want to get to that point where somebody is using a used pack, it goes into somebody's house and there's a loss of life, and then we wake up and then make the rules. It makes sense to act on it now, because the quantum of material coming back to recyclers today is more NMC than LFP, because the LFP journey has just begun in India. But NMC has been used for the last 5 years, 6 years.
Wow. I think within this India EV show, right, this is a second big revelation. The first revelation, which I got in another podcast with another founder of a scooter OEM, that there's no regulation on low speed vehicles. There's no testing now happening, which is one big learning out of this podcast. The second major learning that I'm getting from you on regulation is that there is no regulation on second life. Actually, this has to be, because this is an asset which is going inside someone's house, which can power the batteries, but at the same time it can take lives. So I think we should definitely talk that there should be a regulation on second life.
Definitely, I think it's extremely critical that there should be some standard operating procedure, right? So that people are making packs within that domain, within that regulation.
Absolutely. So there are regulations globally about this.
China is very clearly defined. They for example, they don't do second life for NMC.
They don't.
Not allowed. Only LFP. And for them, they have a very clear mandate. For example, batteries that are used in buses in China end up going as second life into mobile phone towers. There's a clear mandate that it can be used. Mobile phone towers use like a 2+1 kind of, one is like a backup kind of battery. We don't understand why that has to be a new battery.
Oh, that's a fixed regulation that all mobile towers will use
from the bus
battery. Why a mobile tower will need a battery?
Again, grid connectivity, reliance on grid.
They could have used earlier the fuel systems or
lead acid batteries.
Lead acid. Again, they were also on lead acid. Now they're moving towards efficient battery solution, which is a lithium energy.
And longer life.
Yeah, and longer life. Because lithium, this is just 1.5 years. This will run for about 3 years.
Yeah, 3 to 5.
3 to 5. So what I understand, because we work with two-wheeler batteries a lot. So typically in a two-wheeler, the battery runs for about 2.5, 3 years. Yeah, 3 years possibly, or 2.5, right? Now, after that, this is going into an energy storage system, which is what LiCo is doing as of now. And it runs for another 3 to 5 years. Should I put it 4, just for simplicity?
Yeah, sure.
Yeah. So on an average, so 4 years. So one battery pack is now used for about
7
years, close to 7 years, right? Putting it 4.5, right? Now, what happens after this?
After that, most likely the battery is completely consumed or dead. So it has to go for recycling. That means it cannot be used the way it is. Now, if you within recycling, the first step would be mechanical separation, where it would go through a series of mechanical steps, shredding, crushing, grinding, sieving, where you are essentially trying to recover the anode and cathode. And that powder is called black mass.
Okay.
So you're trying to remove all the impurities, no copper, aluminium, iron, plastic. You remove that and try and make that black mass as pure as possible.
Black mass, again, too many things that we would want to unlock in this one sentence of yours, right? Because, and just I want to, before I get into recycling, a little segue, because I heard that after you use the batteries in energy storage, like possibly the tower business, right? Power the towers. After that also, there is some life, because if this one is 100% battery, right? At this stage, when it gets rejected from a scooter, is about 80. So 80% life still left. Yes. Now you're putting it into an energy storage. Till what life?
The batteries we have seen could be completely dead.
What is dead out of 100?
40% or below.
40 is dead. That's when it gets into separation process. Exactly. So you're saying till 80 to 40, I will run it energy storage. And the one thing that I was talking about within this energy storage is, I think now a lot of torches, a lot of mobile power banks are also possibly using. Is that the third life, or
That is the second life.
that is also second only?
So a lot of toys, torches, lanterns, power banks are made from from the batteries that have come back from electric vehicles. They've been bundled together with a connector, and that happens in the informal sector. It's not happening formally, but it does happen in the
Toys and stuff.
correct, because if you notice, if you buy a power bank, it will never last you more than 6 months. Right? That's because it's already been used before. It's not necessarily an A grade battery, right?
Which is what my point was, that maybe it constitutes a third life, because you might have used from 80 to, let's say, about 30, 35 in this, no, not 30, 35%. So basically about 50% you get it here, and then you put it in a toy or a torch and a smaller application or a lantern, because then your usage is lower, right? Because you'll use a toy once in a month, twice in a month, or maybe more, and hence your requirement would be sufficed with that third life.
It could be, but I think that's a bit fair down the road for anyone in our country yet. But yes, a lot of vendors that you see on the streets who have carts, they use lights that are powered by LED lights. In the rural areas, you'll see a lot of torches, lanterns that are used by LED with lithium-ion battery cells. And those battery cells are actually most likely not the first life ones, not brand new ones.
Yeah, they're not, and they might have been in a scooter being used by a zip delivery partner. Yeah, awesome. So now we are coming to the separation process, and can you break it a little slowly, because you said shredding, crushing, and then grinding, and then you also talked about the separation of copper and aluminium. So I think just double click a little bit on this, that while the battery is now about 40%, we consider it as dead. So it's recycling. This is also something that LiCo does.
Right. That's that was the business that we started. When we started getting OEM material, we realized that some of these batteries are so good, they're 90-95% life in them, and we're just throwing them into our shredder and crushing them. So why are we losing value? Why don't we extend the life? Then we set up the refurbishment or repurposing business, where we started testing each cell and finding an application for it. We could not make our own packs until early this year, because we were not getting the consistently same raw material. We would get 18650 cells from someone, 21700 from someone, 2650. So we can't make a defined product. So we have no choice but to grade them and then ultimately give it to a smaller player who would be using it in one of these applications. But today we can say, okay, now we can make our own product, because we have a steady stream of type A, type B. So we know what we can make. And most of the two-wheelers in India still use the same kind of NMC cell, 21700. So now that we have a steady stream on the back end, now we can find use cases on the front end. Because the product had to be the same. If I start making a new battery pack for every OEM, there's no viability, right? It makes no sense. So that's the reason why. Now, so the recycling is the main business.
That's what you started with, which is the third stage.
Correct.
But since you started getting a lot of batteries which are better and not dead,
Right.
you said that maybe I can arrange packs for energy storage also.
And we can extend the life of those cells that we have imported into our country. At the end of the day, we are a net importer, right? We're not making any cells here. So if we can extend that life by 4 to 5 years in a different application, it helps us.
But tell me one thing, that if you shred and take black mass, which we'll get towards, at 70% life, then is it more or less?
No, same. So the minerals will remain the same. The content of mineral, you will have the same percentage of lithium or cobalt in the battery, whether it's 100 or whether it's 20 or whether it's 0. So the content of the metal will be there. So if there's 20 grams of cobalt in the battery, it will remain 20 grams of cobalt no matter how efficient the battery is.
So it'll remain the same. Yes. But is the quality degraded?
No, it's fine. It depends really on how good or efficient your recovery process is as a recycler. But generally, no, I would say that if there's 20 grams in there, if you can recover 19.9, you're a great recycler. If you recover 18, then you're not a great recycler.
So we said that this battery pack was 100 when it had some amount of nickel, cobalt, aluminium in it, right? It's used for 3 years in a scooter.
Right.
It's then used for about 4 to 5 years in various second life applications.
Right.
And then when you recycle and take out stuff out of it, everything is the same.
Well, over time, how it degrades is the way that the anode and cathode work with each other, and like how the lithium-ion cells transfer between them. And over time, the efficiency of that battery will go down, and that is the state of health. But the minerals constitution inside the battery will remain the same.
Okay.
So when we get the batteries, even if they're dead, the amount of minerals in them will remain the same.
Also want to understand that while you're making a battery, there are minerals. What else is making it very efficient, and which is what degrades, right? So just explain, because if there's everything same.
Basically, between the anode and the cathode lies something called a separator. So the lithium ions move from between that, and as that degrades over time, then the performance will go down. And one of the factors, the larger factor would be one of these. And the anode, or most likely anode, is not performing the way it should. The life has come down, and then that's when it would be dead, and then we would recycle it. But within that cell, all the minerals will still remain inside. It's just the performance of the cell is no longer what it was. So when we put it through a mechanical crushing, grinding, making it into a powder.
So you basically take a cell, crush it.
So shred it, crush it, grind it, make it into fine powder, and then remove the other parts of the cell. So within a cell, there'll be copper, there'll be aluminium, there'll be iron, like the casing. So all of that will be removed, and then you've got this black powder left, which is essentially a combination of anode and cathode. That is called black mass. So that's the mechanical process. The next step is a chemical process, or a hydrometallurgy process, where you chemically treat that black mass with acids and solvents. And then you remove lithium separately, cobalt separately, nickel separately in a salt. Then it goes into cathode active material, and then into a cell, and then back into a battery.
Back into a scooter battery.
Correct. So then that is the circular supply chain that we want to attempt.
But at the same time, there's another debate on sustainability in EV, that hey, these batteries create a lot of waste or a lot of issues if what not happens. So that's what we want to debate now. That this, if the process of recycling, which you are into, is saying that one battery is picked up, it's used for 7-8 years, then all the chemicals are separated and black mass is made again, and the battery is going again, then where is the problem of pollution?
The problem of pollution really lies in mining. Mining is extremely energy intensive. Recycling batteries and recovering these minerals like lithium, cobalt, nickel is probably 70% less intensive than mining. These minerals can be used in batteries again and again and again. It's not that they can be used once and they're going to become worse. They don't become worse. They perform the same way. You don't have to compromise on performance. So why is recycling important? Because you're going to generate 70% less emissions than if you mined them. And those minerals anyway are available in very few countries. So if we cannot control that supply chain, we have a problem. And we are a country that is moving at a furious pace towards electrification without having a single one of those minerals. So what the way we look at it is that these minerals should remain in the ecosystem, right? But of course, it takes time. China took the last 2 decades in building what they've built. We cannot catch up in 2 years. Right? It's going to take us 5 years. It's going to take us 6 years. We have to get technology from them, learn them, become better. Right? I think we have good talent in our country. We have good government support, policies on electrification. Let's use that together. Right? And create that entire supply chain so that the minerals remain in India. If we don't have mines, that's okay. Sure. At least 30%, 40% of our supply chain can come from what we're already using. That's the idea.
See, we don't have lithium. I think there was a talk about
Jammu Kashmir.
Jammu Kashmir. Was it true?
Yeah, but we don't know if that lithium can be used. We don't know what is the viability of that. They've had a few tenders where the success has been zero. And even if it is, mining is like a 10-year story. By the time we'll take it out of the ground. Our problem is, what do we do today?
No, absolutely. So what you're saying is whether we have lithium or not in Jammu is still questionable.
Right.
And we'll figure it out. But at least whatever EVs that we are putting now, maybe the lithium is coming from various different parts of the world and a lot from China. But whatever you have got now, at least preserve it and don't throw it. Correct. Or don't supply it outside, which is what US is also doing.
Correct. So the first step is let's not put it in landfills.
Let's not put it in landfills and waste it, because then it's gone.
Forever. And it's also spoiling our soil, contaminating the water. These are heavy metals like cobalt and nickel. So ideally you want to not throw them in landfills. You want to recycle them. Now the first step, which is the mechanical separation, I think we've figured that out. The second step, chemical part, I think we're very early in that in India, and we should try and attempt to get there. But it's the next guys that are missing. Okay. There's a precursor company who will take these salts and make a mix. He will make a mix. Then it's the cathode guy who will add lithium and make his own mix, and then give it to the cell guy who will coat it on a foil and then make the cell itself, which today Ola or Reliance are doing, and Exide and Amara Raja are going to start doing too soon. So we have the cell guy because that was in the PLI ACC.
Which is what Ola picked up.
Yeah, we have the recycling, although nascent, but okay, good enough. What's missing in the middle, the anode guy, the cathode guy, that we still need. And those are high capex intensive businesses. We need people to spend 5,000, 8,000 crores on this, setting up these plants. There's no government incentive for them. There's no guaranteed offtake buyer for them. So who's going to take that risk? Wow. So when that comes, then we can look at circularity. Until then, it's just a buzzword.
Oh, is it? But at least we are getting there. From at least 3 years, 4 years back, when we were looking at a few of our batteries possibly to be recycled, there was no one, right? And we did then research. There's a company, I think, there are a few of your peers who came about. And now I think the industry is at least coming up on the second life. And this mechanical process and chemical separation also. Now you're saying that, and then there's a cell maker also from the back end who's come in. So the middle two guys are a business opportunity, yeah, for people to create businesses, but high capex business.
High capex and difficult technology, not easy, proven technology, betting on one kind of technology. If it's LFP, that technology does not exist outside of China. So how do you get technology from China when they are clearly putting restrictions on exporting LFP technology? So a lot of challenges to navigate. But at the same time, I think the cathode and anode guys need government support. They need buyer support, manufacturing, like cell manufacturing support. And I think there are companies in India who are willing to put money down and build those facilities. And experiment with tech and figure it out. But they need support, because it's not happened without support even in China.
Yeah. Support. What kind of support are we talking about here?
Could be capital support. Could be I don't know if PLI is the right word to say, because I don't think the PLI is really worked out in the ACC model. I think there are problems that the government has seen, and I think they themselves are not talking about PLI anymore. But at least a capex support and having higher tariffs on imported materials so that they can protect the home industry, and ensuring OEMs buy from domestic players, so that, and giving them an incentive maybe to buy, so that I can understand OEMs saying that, but we're getting it cheaper in China, why should we buy it in India? So give them an incentive for them to buy in India and develop that supply chain. I have no doubt in my mind that there's only one country that can really challenge China in this segment, and that is India. Look at the size of our country, look at the consumption of our country. We're at lower unit operating costs. So I don't see how we cannot become an EV hub for the world, not only for ourselves.
Yeah. So what is missing?
Action. I think we need quicker, swifter I think the government knows what they want to do, but I think we get lost in the whole myriad of different agencies. I think we need swifter resolutions, greater focus, faster execution, and then I think things move.
But do you think that, uh, we are all aligned with lithium ion as a technology, LFP or an MCO, whichever, right? But they're all lithium chemistries. Are we aligned on this technology, or we are waiting for some new technology? Is that the reason why we are not super pushing on this agenda, or this one is good enough?
I think they're trying to, see if there are other technologies like sodium ion, for example,
Hydrogen?
hydrogen possibly, but I feel hydrogen is a bit tougher for us to do in commercial vehicles at least. However, I think lithium has been around for almost 40 years. I don't, apart from China, Japan, and Korea, no other country has been able to establish that manufacturing. Tells you how hard it is, right? Tells you a great story there. So I think if it's been that hard for those guys, I think the newer technologies are not going to get any easier. So how do you develop that entire supply chain? I was in China in May, and I can tell you they have sodium ion energy storage batteries ready, and the whole supply chain, anode, cathode, we are still talking right now about anode, cathode in lithium. They have already made anode and cathode of sodium. It's ready. They're ready.
That's where everything starts, possibly, which is also not a bad use case.
Not at all. I think India is super focused on battery energy storage at the moment. You're seeing that with the new tenders coming out. Battery, at the end of the day, if we move towards 100% electrification, how are we going to power these vehicles? Our grid cannot do it.
Can you talk a little bit about this mechanical separation process? Is this via machine? You talked about the human separation, and then?
So the mechanical separation at our facility is a completely automated line. No need for any human intervention, only at the end to change the bags. But apart from that, from start to end, it's a step-by-step, fully automated line. We've got two lines in our facility outside of Bangalore in a industrial area called Vemgal.
Just tell me, if someone wants to create a business in the EV space, which are the couple of opportunities that you would want to recommend people?
I see a lot of recyclers, a lot. Now, I think over the last year, maybe I must have spoken to 30 new guys.
30 new guys in your space.
I appreciate them with stars in their eyes, but it's a tough business. Find your raw material, otherwise don't build a plant. It's not so simple. Don't rely, I tell a lot of them that you've built a business relying on the informal sector or the kabadi walas. You can't do that. That it's not going to be a sustainable model. So, I think recycling is maybe an easier way to enter this business, but be sure. I'm not saying that the opportunity is not there. Of course it is. That's why we're there. But be sure of what you're doing. You would maybe agree with me because there's so many two-wheeler companies. Right? When you started, how many scooters were there, and today how many are there? Sure. But over the last 8 years of your journey, you've seen how many come and go.
I see a new two-wheeler rental company every second month that I go out on ground. I go out every month. Every second month, there's a new two-wheeler EV rental company with a different color. And after 6 months, the color is gone and the name is gone. But I see two more new within that time, colors and names. But I think that's what possibly is happening everywhere, that people are finding EV as an opportunity. But they are now, at least we have enough data points for everyone's benefit. I'm sharing that now we have enough data points of successes and failures. Either just don't jump into it. Just analyze what people have done, how easy it has been for people to sustain those businesses in your space or in any other space, and take a conscious call. Solve the problem that possibly you are facing or we are facing, or anyone else who's tried this is facing, because there's still a lot more things to do. Like you said that I am still finding tough to find suppliers for raw material. That could be a good opportunity.
Definitely. That I think in our space, raw material supply sourcing is the largest challenge. Not only for us, I think any battery recycler in the world, it's the same story. We are importing material as well because it's difficult to find enough material in India to fulfill our capacity. It's difficult to import because it's a hazardous waste. We have spent 1.5 years trying to figure that out. Now we can say that, I can't say I've figured it out, but I can say we're on our way. In our industry, we learn something new every day, right? I think every single day, every single OEM, every single battery, I learn something new. And that's what excites me. Every time I feel that, okay, we know this, I think something else comes from behind and slaps us across.
I can imagine what you're saying because I'm going through the same for the last 8 years. Every day there's something which is broken and still being solved, and not one, possibly a few more things, right? And that's the, if you are of that grit to get into the mud every day, figure out and possibly feel that maybe you might, get inside it only and still come out with that one hand, then get into an EV space.
Yeah, absolutely. Otherwise, find a stable business, set up a t-shirt company or something,
Which is solved and be creative.
I mean, set up a rolls company, something like that, tried and tested. If you want to be in this industry, I mean, give up on sleep, and it's not a standard, 9 to 5 kind of industry. No way.
But what motivates you? Again, now I want to talk about that. Yes, we've talked about so much struggle and, it's not a hunky-dory industry. Still, you are part of it and you picked it out of your choice. What motivates you to get up every day when you see so many challenges?
I find it exciting that we find solutions to problems every day, every month. There, you can imagine how many different kinds of batteries there are, how many different chemistries there are, how many different form factors there are, so many different battery OEMs, vehicle OEMs. We get different kinds of batteries every day. So solving those challenges, now we're importing batteries. Again, the kind of batteries in North America are completely different. More pouch cells, right? We don't get so many pouch cells here. So different dynamic. How do you discharge them? How do you crush them? How do you recover from them? So I think that's what keeps us motivated. That every day there's a new learning, and when we think that, okay, now we kind of figured out mechanical separation to a large extent, how can we go downstream? How do we set up a chemical plant? And then the learnings from there. So it's going to be a continuous journey, and we keep learning.
So there's a question powered by one of our sponsors, MotoVolt, and they're asking that is there enough technical talent in India to solve an EV recycling or a battery tech business?
Yeah, I think so. I think, first of all, I think that we have a rich chemical background. We have a good talent pool of chemical engineers in our country. We have, I think, a good understanding of electronics. So if it's the chemical part, the downstream part, or it's the battery pack building part, I think that we have the talent. I think we just need to be clear on our policy and go down that path. I mean, I find, young guys building packs in their garages, with not necessarily, having like an electronics engineering degree. That's the kind of country we are, right?
Yeah. I recently saw some village where someone has built an EV car, and there was a video on how it's being compared to Indian Tesla or something like that. Yeah, there's a video which came to me on a group. So there's a comparison like that. Someone has made.
But that's amazing. We're the country of Jugaad.
Correct. We're a country of Jugaad, and we can actually do so many things. Yeah. What are the common mistakes that you see entrepreneurs doing or they should avoid?
Be agile. Be flexible. Our industry moves at a furious pace, quicker than you and me can think. There are many factors, right? It's not only what we're doing in India, but we're influenced by what's happening in the rest of the world too. In terms of technology, in terms of consumption, in terms of so many different things, policies, regulations. So I think that being flexible and being able to constantly evolve, that's important. Don't stick to one thing and think that this is my plan for 5 years and this is how it's going to be, because it never really works out that way, what I've seen at least.
Yeah, be ready to change.
Be open to change. Listen to people. Go and learn from those guys who have already done it better than us, or quicker than us, or earlier than us.
Since you are also in the EV ecosystem, and we have another partner called Redon, they are into battery space, right? And they are also into. I'm sure they would also look at players like you. So you should. I'd love to make that connect between the two of you. But I think the question is that as we talk about LFP, and then there's NMC, and then there's possibly solid state and sodium ion, right? Is recycling process going to remain the same even if the technology evolves, or there are tweaks that will need to?
There will be tweaks. Today at our facility, we are chemistry agnostic. That means we can do LFP, NMC, LMO, LCO, everything within our roof. But as things change, sodium ion or solid state, we may need to tweak our processes. We may need to have a dedicated line for that. That may take time, but we need to, of course, do R&D on that and figure it out. But that's one of the points, that again, be open to change, right? It is. I don't think anybody spoke of LFP when you started your business at 2018, right? Today, it's a dominant force in India.
Yeah. LMFP also came out of nowhere.
And today, I don't think too many people in India talk about solid state or sodium ion, but that may change in 3 years or 5 years. So your 5-year business plan that you've made, and thinking about how rosy the world is going to be, might be out of the window in 3.
Oh, my first plan was out of the window in 3 months. not 3 years or 5 years. Within 3 months, I lost the plot on my first, story which I built, which is bike sharing. That's how we started. And within 3 months, I realized that what I've gone into, because the business model doesn't work in India, and probably globally also, right? So yeah, that's how.
But look, you pivoted, right? That's the point.
Any myth about EV industry that you want to bust?
I think there are people who still say that electric vehicle also is polluting because of the way it's mined. I guess from the way it has been mined and comes to us, we're using electricity, so it's still not clean. But I don't think we can compare. I think ICE engines have had 100 years on us on electric vehicles. It has to be given some time. As you said, India is almost 40% renewable. So I think there are plans in place. We are on our way. But I feel that there's no question that electric vehicles are better for our environment than ICE. There are some people who may not think so, but I definitely think.
Got it. And what do you think about our path to renewable? Have you got any thing going there? How fast are we moving towards?
I think faster than expected. Right, I think we are ahead of our targets as what was agreed in the COP, I think. So I think the government understands the focus on electrification has come from where? That our largest, import bill is petrol. So how do we get rid of that and reduce dependency and reduce money flowing out of the country? So I think that is the basic fundamental problem that they're trying to solve.
Got it. And EVs are moving in that direction. Yeah. Lead acid was coming from where? Did we have the lead acid content anyways in the country so we could make the cells?
Like big players like Amara Raja, Exide, they make lead acid batteries and of course distribute them not only in mobility, but then there's Luminous and V-Power, V-Guard, or many companies that supply them with inverters as well. We're trying to use the same inverters that were sold across the country and make our LFP batteries to match that inverter rather than reinventing the wheel.
One application, second application, that's what we spoke of. Yeah. Awesome. Any policy tailwinds that you feel, while we talked about a bit of regulation, that can actually unlock the recycling industry?
Bring material to India, make it simpler to import. The more material that comes to India, the more money recyclers can make. The more money recyclers can make, the more money they will invest in capacity and in downstream and the next step and the next step. So the ease of material coming to our country is important. That should be a quicker, easier, simpler, in my opinion, a simpler way. if we categorize these as critical minerals, as our finance minister does, and not only them, but from Niti Aayog all the way, then why is it so difficult to bring it into our country?
Is it very difficult?
It's classified as a hazardous waste, so it's difficult, yes. But we can try and make it simpler, at least to apply to get permissions to bring the waste. And as that comes in, there are so many countries in the world that don't have recycling yet, but they do generate waste, right? So why can't we bring that in and process it? Build our industry. We should look at being a processor for the world. We keep looking very inward, in my opinion. We should look outward. We should be a processor for the world. Why are we looking at only India?
So you're saying that allow the downstream material import to upgrade it.
So let batteries come, let end-of-life batteries come to India. Whether we use them in energy storage, whether we use them in recycling, whether we go down to the chemical part, we go down to the cathode part, all of that will happen step by step. That will happen only if material comes, if capacities are being utilized, if guys are making money. If they're not going to make money, if they're not going to use their capacities, how do you expect them to go down the road?
Got it. Last point on recycling. I want to know about how the pricing mechanism works, just for people to understand. Let's say a typical battery pack, and I understand two-wheeler is about 40K, right? That's typical price, or 50K, whatever you want to put. How does that money flow happen till the end of life?
So two parts that go into pricing a battery. One is if there's a reuse factor to it. That is directly proportional to what is new cell prices, right? And when I say cell price, I mean energy storage, not electric, because you are probably buying a battery that is suitable for mobility, so it's a higher spec than energy storage, and perhaps more expensive. But when we get it and we're putting it back in energy storage, we need to be at half the price of a brand new cell. Otherwise, there's no market for us, because we are not able to give half the warranty period, right? So the first factor is, as cell prices decline, our offers to OEMs keep declining. So we were at $100 a kilowatt hour. If today we're at 50, we have no choice to go at 15, 20. Second factor is the minerals found, the metals that are in the batteries themselves. If those commodities are at a higher price, lithium, cobalt, nickel, we can offer a better price. But if they are at a bottom, which they are today, we can only offer a lower price. We can only recover what's in them. We can't put anything else from our side. So that is our point. I understand OEM's disappointment when they tell me, Gaurav, we bought these at $200 a kilowatt hour and you're talking about 20. Yeah, I understand you bought it at 200, but you bought it 5 years ago when cell pricing was there. Today's cell pricing is at 50. So I can't help you.
But new batteries are still not being bought at 200 now.
Exactly. Yeah. But when they bought it 5 years ago.
But they're still at 180, not at 50, right?
Depending on quantity, so many different. And again, depending if you're importing cells, then much lower.
How big is this industry going to become, the second life or the recycling industry that you're into?
The second life business, I believe, the possibilities are endless, because the energy storage is a huge business and we are still an energy deficit country. The recycling business, to put it into perspective, I think, we are at a point where by the time it's 2030, we're looking at least in terms of just raw material availability from a 12 to 15x point from today. So we feel that we will not have enough capacity at 2030. We don't know how many more players will be there at that point, but we will need to build a serious amount of capacity to meet the end-of-life batteries that will be available in India at 2030.
I think I'll now ask one personal question. Father's business, joined that, your business, that was easier, this was tougher.
Every business has its challenges. There's no easy business.
But what should someone do as a young person who's listening to this podcast? That a lot of people either when they have family businesses, they're typically not starting up on their own because they possibly get into the same family business, versus you took that call. Is there a method to this? for someone to make that leap of faith?
I'd say there's no hurry. You don't have to start it tomorrow. Go learn, work with somebody who's doing this. Learn, spend a year, understand where the material is coming, where it's going. Is it feasible? Does it make sense? What are the good processes they have learned? Right? Learn, educate yourself. Don't guess stuff. Don't read a report that shows you, oh wow, there's going to be an explosion of batteries. Yeah, but there's going to be an explosion of recyclers too. So be careful. Be careful with your money. Go work for somebody. Learn for 2 years. You don't need to open a battery recycling company in 2025 to be successful. You could do that in 2027. There's no rush. Just be very thorough before you come in. That's all I have to say.
Got it. No, thank you so much, Gaurav, for sharing amazing insights about battery recycling. I personally understood a lot of things being in this industry, but as we all know, I don't know whether you were part of the EV industry. No.
No, not before.
Same here, even I was not part of the EV industry, and I think no one that I meet also were part of the EV industries, but all of us are building EV businesses without any prior background. But since this is a new industry, possibly someone had to take that leap of faith. Yeah,
absolutely. And that's the amazing part, that it brings together so many different people from different experiences that have all come together in this industry.
Yeah, quite interesting, right? So look forward to the EV India electrification story. Thank you so much, Gaurav from LicoMat, to share so many amazing details. And I hope you all learned something more about the EV industry. Learned something more about battery recycling, and we'll keep learning. We'll keep sharing more insights, keep subscribing, and keep putting in what more you want. Thank you so much, Gaurav. You were a great guest. Thanks.